Hey woodcutters, Topsaw here. Today I was going to go over some key ideas in CNC wood manufacturing. I am going to go back and forth between the CNC running and the CNC software, but it's really not CNC software specific. I'm going to use Mastercam, but I'm really just trying to highlight all the different ideas. So here's a cutting board right here drawn in Mastercam. Again, this isn't about Mastercam, it's really about CNC manufacturing and wood. And what I'm going to go over today is how you're going to do your stock setup, whether you decide to run it in the top, in the center. Then we're going to go to your parameters. And then in those parameters, we're going to look at the tool, the cut parameters, the compensation type, what depth the cuts are, what lead in, lead out is, what tabs are, and linking parameters, setting depth if you call top of stock 0. So that's what we're going to be going over in this video. And I'll go back and forth between these settings and the video of it running. So I have my board screwed down on the tabletop. I have that pencil X marking the center of the board. And then I bring my cutter right over that and right on there. And then I zero my machine because I'm calling that top of stock, 0 and X, 0 and Y, 0 and Z. So right here, this is my property manager on my left-hand column here. And this comes up after I pick my machine type. And then under this, I'm clicking on stock setup, and this is my stock setup. So the piece of my material is 13 inches in X, 9.5 inches in Y. And with the dial caliper, I check the thickness of 0.43. And this is really important. I decided to say the middle of my stock is 0. And that's my origin, and it's top of stock. So top of stock. Next, I'm going to look at toolpath type, the tool itself. You can see that's a 1/4 inch ball end mill. And then also the feed and the plunge rate. How fast it's traveling right here is called the feed rate, and it's traveling along a designated line, which is a contour. Let me show you that in the software. So here's my design. I'm going to look at parameters now. First thing we were talking about, the toolpath type. A contour is following a line. A pocket is routering out a big flat area. Facing is preparing your materials to work. Next thing we looked at is tool. I've selected a 1/4 inch ball end mill. I find that in my tool library, these are all the tools I can use. So I select it from here. And then next I go to my feed rate. That's this. This is usually found on a chart. I've selected 100. That is how fast it is traveling. And then the plunge rate is usually set to half of that. And that's this, and that is how quickly it goes into the material. Okay, I just finished cutting that blood groove on a single cut. That's cutting the hole 1, 2, 3. So those 3 depth of cuts. Let me show you what that looks like in the software. So this setting right here, depth of cut, is a maximum depth that'll go into the material on a single pass. Good rule of thumb is less than the diameter of the cutter. This is a 1/4 inch bit. My wood is only, less than 3/4. So if I set it at 1/4, it's going to do 3 passes. And that's why I count it to 3 when it's cutting out that circular hole. Now that it's cutting out the hole, now it's going to go over and cut out the part itself. A couple things we're going to talk about here is direction of travel and compensation type. Look at that cutter or the router bit. It is on the left side of the line. That is called left hand compensation, and it keeps it outside of the part. I am also traveling clockwise around the part, and that's going to give me a climb cut. When I cut the hole out, I had left hand compensation, but I was traveling counterclockwise, which kept it inside of the part. So that's compensation type. Watch this. It just plunged down at a plunge rate of 50 inches per minute, and it's doing its second pass because I set the depth of cut a 1/4 inch. So the first pass was a 1/4 inch down. The second pass is a 1/4 inch past that. So now I'm cutting a 1/2 inch down into the material. Let's look at the software where those settings are. Okay, I'm in Mastercam. I click on parameters. We're talking about cut parameters. I have it on. And you can see in this direction of travel right here, the bit, the router bit or the cutter is on the left-hand side of the line. That's a left-hand compensation. That's what that means. And as we look at this router bit going around, again, this thing is spinning clockwise looking down on the router, and it's also going around the part clockwise, that is a climb cut because it kind of climbs up the material, versus if it was going the opposite direction of travel, that would be a conventional cut. And then, I don't know if you can watch this, it's really slight, but if you see that bit go up and down a little bit, let's see right there, you see how it bumped up and down? Those are tabs, and those little tabs are a way to hold the part down to the tabletop. So they leave a little bit of remaining wood left, and I'll go ahead and show you in the software how you set tabs. Here we are in parameters. Down here is a tab button. I'm going to click on that tab. I'm going to select it. I'm going to put on automatic tabs. This is how many tabs it'll create. You can make as many as you want or you feel appropriate. You could create them only on small pieces or on all pieces. You could set the width of the tab, the thickness of the tab, all those settings here. A couple other things while I'm here I'll show you is that lead in, lead out. I usually deselect for woodworking. What this does right here is it allows the router cutter to enter outside the part and then cut into it sideways so you're not plunging with the tip of it. But it's going to screw up your whole cutting board in this case. I turn that off. Last thing I really want to talk about is fixturing it down. If you leave those long wooden tabs at the end, you could actually screw it down to a sacrificial board, which is a good way to go. We also use plastic nails on occasion to hold it down, but you got to make sure the way you fixture it's not going to damage the router. So here we are pulling the screws off, and it didn't actually pop all the way up away from the holding points. So what we do from here is we're going to go over to the bandsaw, and we're just going to cut off that excess, being really careful not to damage the board. And then once that excess is cut off, there's still a little bit left, also because we used a ball end mill. So we're going to go over to the flush trim router bit table, and then just flush trim that last little bit of wood on there, and then it'll be a perfect part. A little bit of sanding, it'll look like new. I'm going to cut out this one more cutting board and just kind of talk you through it. The router is set on 16,000 RPMs. That's the speed of the rotations. This is a 1/4 inch ball end mill. It is following a contour around. The depth here is only 1/8 of an inch. So my depth of cut is set greater than that. Just going to cut this blood groove out in only one pass. But as it comes over to the hole it's cutting out here, it's going to travel counterclockwise with left-hand compensation and cut that hole out in 2 passes. When it's finished cutting it out, I actually have it set to do some finishing passes to clean up the cuts a little bit. I'm going out to cut out the part now. It is also left-hand compensation. However, it is traveling clockwise around the part, and that cutter is also spinning clockwise, so that is a climb cut versus a conventional cut. On the hole in the center of the board, it was traveling counterclockwise and spinning clockwise, and that was a conventional cut. You can see right here it's going to plunge down at 50 inches per minute to do the second pass, and as it bumps up and down there, it's leaving little tabs in there, and that's going to help fixture the whole board down. This board is only a 1/2 inch thick, so the whole thing got cut out in 2 passes, and the depth of cut was a 1/4 inch. It's all done running right here, and then it's going to go back to the origin where it started. When you pull a router out of there, you always Z up away from the part, and then fixturing is also a big piece of this. Well, I hope that video explained a lot of the key terms and ideas of CNC woodworking. Please comment below if you have any questions or more ideas on how to work with CNC woodworking.